Hey everyone, good morning, good afternoon, good evening, wherever you're watching the stream from. We are back with another workshop. Today with us, we have Alex from Redstone. Alex, would you like to introduce yourself and take over with the workshop?
Sure. So, I'm Alex, a software developer at Redstone, where we build the next generation of EVM compatible oracles. And today I would like to tell you about Redstone, about how the Redstone oracles work, and how you can use them on the Celo blockchain. Okay, so can I start?
Yeah, please start.
Okay, sure. So first of all, let's start with oracles and why are they really needed for the DeFi space. Uh, let's just imagine the world without oracles, and the DeFi world without oracles would be very, very poor. A lot of use cases just wouldn't be possible to create without oracle data, without data from real world, because of the blockchain nature, because each blockchain works as a decentralized computer. It's trusted, secure, cryptographically secured, and quite expensive, but still it's a computer, and it is an isolated computational system which cannot access external data, like cannot query some external API. And without data from external world, for example, pricing data for public assets like cryptocurrencies or for stocks, or just weather data, or data about some sport events, it's really difficult to create a lot of use cases based on this data, because lending protocols, synthetic tokens, derivative protocols, different kind of insurance protocols, all of them require data from real world. And this is why oracles exist. They try to solve this problem. They try to connect data from real world to blockchains. So yeah, you can imagine if blockchains are decentralized computers, then oracles are like internet connection for these computers. Uh, you can ask why oracles cannot be just built in blockchains directly. This would really simplify everything, because if blockchain can query external APIs directly, as like from the smart contract code level, it would be way easier for developers. But unfortunately, this approach would create a lot of inconveniences and security issues even. First of all, because blockchains are deterministic by definition, which means that for given set of inputs, they will also produce the same output. But nodes can join the network, can join blockchains in different time. And if they would query external APIs, the results of these APIs, of these queries, would be different. And this would not be deterministic. So this is the first and main issue, the lack of determinism. And the second part is just lack of security, because thanks to this isolation in blockchains, uh, the technology just becomes way more secure. So these are the main two reasons why blockchains do not have built-in oracles. Some blockchains actually have. Actually, Celo has some kind of oracles built in, but they're very limited in terms of amounts of data and types of data that can be used on chain. So what oracles usually do is they fetch data from multiple sources. Usually they deliver pricing data, so they query different exchanges, their APIs, different commercial APIs. They query even decentralized exchanges on other blockchains. And then they aggregate the data from different sources. So for example, for pricing data, they can take the median value of all sources, of all the values that they got from different sources. Then this aggregated value somehow is being pushed to blockchains, uh, different blockchains, because on each blockchain you would like to use this data. And then decentralized application developers can consume the data and create a lot of interesting dApps based on the data. Usually, as I've said, the main use case for oracles is pricing data, providing pricing data, because it's DeFi, so some financial information is extremely helpful for the majority of use cases. But as I mentioned before, other types of data, like for example, weather or results of some sport competitions, or just like some political data. Everything can be used on chain and for different use cases. So yeah, this is what basically oracles do. They deliver data on chain, and the main approach that oracles have is that they simply query the data and save them in some Oracle smart contract storage. Oracle smart contract is kind of a multi-sig secured contract where only a limited set of data providers who have some financial incentives can push data. And this approach is quite convenient because developers then can simply ask this Oracle contract about the latest values and get the latest value. It's really easy for developers. But unfortunately, because of the storage costs on blockchains, this approach is not really scalable. Because first of all, blockchains were not designed to store large sets of data. At least smart contracts blockchains were designed to compute different things, to have secure computation, but not to store large sets of data. So this is the first and the main reason why this approach is not scalable, because it's just expensive. You need to pay a lot of costs just to store this data, and if you want to update them every 10 seconds instead of every 10 minutes, then your cost will grow up 60 times, which is extremely high. And like, you cannot update data frequently, you cannot add more data, which would make the system more expensive. And that's why oracles usually provide really limited subset of tokens, like usually the most popular tokens. And they update data in intervals, sometimes at 10 minutes, sometimes even less often. So yeah, and another problem with oracles is that with this approach, you need to push data to each chain separately, which makes yeah, there are good oracle providers, but sometimes when new chains appear, oracles just are not ready to launch on the new chains, and people use custom solutions which are not secure and which cause security issues for decentralized applications. And these are the main points which we at Redstone are trying to solve, because we switched the model. We have a different idea how oracles can work, and that's what we created, and that's what we are creating and improving all the time. And the main difference is that instead of pushing data to blockchains, Redstone data providers sign data packages, just sign data using their private keys in the same way as users sign transactions. But instead of pushing signed data packages to blockchains, these signed data packages are being broadcasted. They're kind of available in some decentralized cloud system, which serves as a so-called decentralized RAM. It's quickly accessible and cheap temporary storage. And using this temporary storage, each user on any target blockchain can query the data from this decentralized cache storage and attach to their transaction. And then this upgraded transaction with the attached signed data from data providers can be pushed to the target blockchain and be used on chain, because on chain you will be able to verify the data integrity. You will be able to check if the signature of the data is valid, if it was created by the trusted signer or trusted signers. You can check if the timestamp of this data package creation is not too old. For example, if it was created only during the last 3 minutes. And if all these conditions are passed, you can forward the data to the target DeFi contract and use them securely in the same way as you would use them with other Oracle solutions. But yeah, thanks to this approach, there are a lot of data that can be provided, and the update frequency may be even 10 seconds, even less. But it really depends on the use case. But thanks to this fact that data providers do not push data to blockchains, it really makes the system scalable, because you can put a lot of data. You can provide thousands of different assets. You can update the values of their prices each 10 seconds or even more often. And that's how the Redstone Oracles work. So yeah, when you, as a user, try to send a transaction to the blockchain, which should rely on the Oracle data, then we automatically fetch this signed data package from this decentralized cloud storage, temporary storage, and we attach this serialized data with signature to the transaction. This is the example where you see that like we wanted to do some action which rely on AVAX price, and here before the actual transaction signing, we fetched the data and attached the data to the transaction call data without using this expensive smart contract storage. And then this upgraded transaction is being broadcasted to the blockchain, and it works like as usual transactions. So to just mention again the advantages of this solution, is the first thing is that it's convenient because you can still have the latest values appended to a transaction, but it's also flexible because thanks to this scalability improvements, you can query different APIs, you can query a lot of data sources at really low cost comparing to other Oracle solution. And another advantage is that this solution, the beauty of this solution is that it becomes cross-chain right away. You can query the data and use it on any chain. We have tooling for EVM compatible chains, but there are a lot of EVM compatible chains, and that's why it's available on many chains, even more than this list, but at least these lists. And of course on the Celo blockchain, which was one of the first blockchains where we were testing the solution. So yeah, if we talk about the architecture of the general architecture, how this broadcasting layer or decentralized cloud or temporary storage layer works, we have a lot of different words to call it, but yeah, this is the simplified architecture of the Redstone Oracles. We have different data providers. Each data provider has its own private key, and each data provider fetches data from the different sources, aggregates the data, and broadcasts them using the broadcasting layer. So how does the broadcasting layer works? First of all, the actual broadcasting happens using the streamer network. This is the logos of streamer network. Streamer is a decentralized pub sub network, which is used to like broadcast data. It doesn't store data for any time. You just like push data to any streamer node, and it will be broadcasted to the whole network. If you are a streamer node, you will listen to each kind of piece of data that you would want to listen, but you should listen before this moment of broadcasting. So this is important that streamer doesn't cache data. Streamer doesn't store data for a longer period of time. That's why we have so-called Redstone cache nodes, which are part of the streamer network, but they also store data received from the streamer, and they store them for like some period of time, for example, for 7 days. Actually, the majority of use cases relies on the latest values, so it's even it would be even okay to store only data for last 1 hour, but some nodes store data like all the data. Some nodes store for the last 7 days. Some cache nodes actually store data for the last hour. But there are also use cases that should rely on historical data, historical Oracle data. And for this case, we utilize Arweave blockchain. Arweave blockchain is kind of an exception in terms of data storage, because I said before that blockchains were not designed to store large sets of data, but Arweave actually was. Arweave was created as a blockchain to store a lot of data. It's something like a PFS plus Filecoin, but technologically a bit improved version of this, and it's extremely great for storing historical data. They also have a layer called permaweb, which means that you can store data there and pay once, and then the data will be available forever. And that's why our cache nodes, we have a special set of cache nodes, which we call archiving nodes, which actually offload the data to Arweave all the time. So users will also be able to access the data through Arweave. Arweave indexing time is sometimes not too fast, But after a few hours, you will be able to get the data from Arweave directly, which is also very cool. So yeah, this is how the broadcasting layer works and like storage layer works. And these are the main places from which users can query the data and use them on target blockchains. These are just like few examples of target blockchains. You can also go to showroom.redstone.finance and see and even try to play with examples for each target chain. So as I mentioned, there are all EVM compatible chains can work with the Redstone Oracles, but for now, of course, we will be focusing on Celo, and I will show you actually an example of DApp built on Celo, which relies on the Redstone Oracles. Just to reiterate why we use Arweave, first of all, of course, it's the cheap and permanent data storage, but other than this, Arweave also gives us full track of records, and it kind of stores the provider's activity. And you as a user, as the consumer, will be able to see the whole history of some data provider activity. This is not a problem for this standard Oracle approach where everything happens on blockchain. This is also available there on each chain. But here it would be a problem. But with Arweave, it's not a problem. You still can have this kind of accountability for each data provider. As I mentioned, Arweave is great for easy access to historical data because you can query data are there forever, so you can query them at any point of time. If your DApp, if you, for example, are building some options DApp or some kind of insurance DApp, and you would like to settle your option at any point of time in future, starting from some timestamp, Arweave also this is the great solution for you because you can use Arweave to query each historical data package you want. And also we use Arweave. We actually built some kind of a smart contract layer on top of Arweave and use it to manage data providers in a decentralized manner. If it goes to our data, what data is available with Redstone Oracles currently, so we use more than 40 sources because, as I mentioned, it's quite important to have a lot of sources, a lot of reliable sources for data, because otherwise, if you have few sources, you are really, firstly, your solution is not decentralized. Secondly, it's not really stable because if you have one source and this source goes down, your DApp goes down. If you have one source and it starts providing incorrect values, which sometimes happen, and actually it causes huge losses for dApps. So again, like your protocol can be hacked, data can be manipulated, which is not great at all. That's why we try to integrate as many sources as possible. So yeah, currently we have 40 sources and provide 1,000 assets, mostly cryptocurrencies, but also data from standard financial world. We also integrated recently some custom data like scoring profiles from the Lens protocol. We also have a solution for custom URLs, which I will show you more a bit later. Yeah, as I mentioned, at least for each popular data feed like Ethereum price or Celo price, we try to use as many sources as possible. For Ether price, we use 40 sources and we take the median value. So here you can see that like the median value is actually looks like the truth because it's the median value across all of the values from different sources. But we also use some other off-chain and on-chain data aggregation algorithms to ensure the security and ensure stability of the data, and to make the data manipulation way harder for potential attackers. As I've said, we have a solution for you to register custom data feeds based on custom URLs and so-called JSON paths. JSON path is a language it's like something similar to XPath, where you can describe how to extract some value from the given JSON. So to reiterate, before going to like more practical part of this workshop, where I will show you pages, links, and pieces of code that you can use and be based on. If you ask why should I use Redstone, the answers would be you can just consume way more data than with other oracles, because newly launched or less popular tokens are already available on Redstone. If you build some kind of DeFi protocol, something like leverage trading, it's definitely worth to have fast update times. You just cannot, usually you cannot afford 10-minute updates times, because people would just, arbitrage would kill your idea. If you want to have non-standard data feeds, you definitely should check out this custom URLs feature, because you can register any kind of data using this custom URL registry. Yeah, and the last point, you can build on Celo, but your app would become cross-chain right away. You can also deploy it on any other chain and it still will be usable, because, as I've said, the beauty of this cross-chain Oracle design is that users can use it on any target chain. And also, I'd like to announce the small bounty that we created as a Redstone team. So the best 5 projects that will just successfully integrate Redstone Oracles, not Redstone API, but like Oracles to the smart contracts, will get $100 bounty. So yeah, now let's go to the more practical part of this workshop, and I will show you the main places, the main resources where you can find more practical knowledge about how to integrate Redstone. First of all, you can definitely check out Celo documentation, because here you have the Oracles item in the left sidebar. If you expand it, you will see the Redstone Oracles article. It's quite short, and it briefly describes what I just described, and also it has a few helpful links for you. But another useful link would be the Redstone.finance website, because here you can also find everything you would like to have to integrate Redstone. If you click Start Building, it will redirect you to the Redstone documentation, where everything will be briefly described. So moving to the part of what data are available, as I showed on the slides, there are a lot of different types of data that are available, and you can check them on app.redstone.finance. You can click on any data feed and see this actual chart of different data points of different values from different sources. Yeah, what is really interesting is this custom URL feature. If you go to app.redstone.finance, you will have this link on the left side. If you click this one, you will go to the app that can be used to register your own data feed. So for example, let's click on, I don't know, temperature in New York, which uses this API. It's already registered, you can already use it, but you can also test if this URL and this JSON path work correctly currently. Or you can register your own URL and JSON path, which should be unique. So let's add this URL again and see what kind of data is also available under this URL. So this was the temperature in New York City. Okay, so it has current weather, and for example, it has speed of wind. So you can specify your JSON path expression. Let's specify current weather, and you will see the result of this expression on the right side. And let's use wind speed. And then you can simply add any comment you want. For example, wind speed. And click subscribe button. I will not. Oh, okay, it already exists. But yeah, if it would not exist, you will be able to to register this pair and use it in your smart contracts. So if you want to check the historical data of custom data feeds that were registered by some other users or by you can go to this custom tab in the Redstone app and just like click on any. Oh, actually, this is the wind speed of at NYC. You can click check the chart because our Oracle nodes for custom data feeds, there are 2 of them and they deliver data with 1 minute update interval. So yeah, and then you can use them in your smart contracts. Okay, so and this documentation actually contains the short and concise information of how to integrate Redstone Oracles into your DApp. And now I would like to show you an example of a DApp that actually uses Redstone Oracles and it's deployed on the Celo AlphaJaris testnet, which is a very, very, very simple NFT marketplace with a single difference that it has so-called stable prices. So you can mint NFTs and you can post sell orders for NFTs, but each NFT you specify price of the NFT in dollars, but the actual payment will happen in native tokens. So here in Celo tokens. So for example, if I post a new NFT on sell, for example, for 0.5 USD. Yeah, firstly we need to allow the smart contract to transfer this NFT. Okay, yeah, so this one went to this right section with orders. Now let's switch the account and try to buy it. So I switched to another account. Now I see this NFT number 1 posted for 0.5 USD. And if I click buy, the MetaMask window will pop up and the price will be automatically calculated and required by the smart contract. And this price actually is equal to $0.5. So let me show you how it works under the hood. So if we open the network tab and click this buy again, you will see that before the MetaMask window appears, actually before the transaction is being created, there are 2 requests to this decentralized cloud storage with the special gateways are being sent, and you can see the data that is returned from these gateways. So the very important piece of data is the signature, but there are also identifier of the data point and the value, the current price of Celo token. And there are also there is also a timestamp. What's interesting is that like if we see the ending of this signature, it's like 6E1B. If we go back to the MetaMask and switch to the hex tab, you can see that the ending is the same 6E1B because the data has been appended to the transaction call data, because first part of the transaction call data is usually function signature and arguments, but the last part is kind of available, and we add these signed data packages to this part of the transaction call data in the end. So and now you can click confirm, and the NFT will be purchased by you, and you will have it. So this is basically the idea of this DApp. It's very simple. It was created. Oh yeah, now I have this NFT. This was created just to demonstrate the use case of Redstone on some on the Celo testnet. And now let's get to the code, and I will briefly show you what are the main steps to integrate Redstone in your DApp. So first of all, you should install the Redstone EVM connector. Everything is described in the documentation, but first of all, you should install the Redstone EVM connector library. It's already installed here, but you can install it using yarn at Redstone EVM connector or npm install Redstone EVM connector. That's it. Then you have to do two things. First thing is you should extend your smart contract with the Redstone price-aware contract. It's located in Redstone EVM connector library. You can make your contract be price-aware, and then you can access the Oracle values using this special function called getPriceFromMSG. You can pass the identifier of the asset that you want to use to this function. All the values are integers and are multiplied by 10 to by 100 millions. So you should remember it while doing any calculations. Yeah, after extending your smart contract and adding price aware to extending price aware contract, you should also specify what signers do you trust. Here is the comment that describes how to get the information what signer you want to trust, and it's usually it depends on the data that you want to use. So if you want to use custom Oracles data, you should use one signers, like two signers. If you want to use the main everything is described here under this link. Yeah, and you also can specify the logic for the timestamp validation. So for this test use case, I've disabled the timestamp validation logic, but you can still have it. For example, something like received. If we comment this out, you can specify something like received timestamp should be bigger than current block timestamp minus 3 minutes. Yeah, this would require changing the function to the view, but it still will work. So it means that received timestamp, the data should not be older than 3 minutes from current block timestamp. And this is generally advised to have something like recommended to have something like this. But for test cases, it's enough to have just true. And yeah, but for production use cases, you definitely should have some condition for timestamp. And yeah, this was the first part. The first part is to update your smart contract. But there is also the second part, which is you need to integrate you need to wrap your smart contract instances with the special Redstone wrapper. It makes a lot of magic under the hood, but the basic magic is that once you do something like this, you have the contract instance. Usually it's Ethers.js contract instance. And once you wrap it using this wrapper builder and specify the data feed that you want to use and specify the asset that you want to use, for each method, for each transaction function that you would like to use on this contract instance, before actually creating the transaction, it will automatically do this magic with querying this decentralized cache layer, getting the latest signed data packages for the specified data feed and specified asset, and it will get the result, will serialize it to the byte structure, and will update the transaction call data and append this data as I showed you in the MetaMask window. So it will update the transaction call data, and only then the transaction will be passed for signing, and then it will be signed, broadcasted. Yeah, so all this kind of dirty work of getting data, attaching data to the transaction, and like passing transaction further is being made by this code. So you just need to wrap your contract, and then for any function it will work. It will happen automatically. You don't need to add any other kind of code here. So let's maybe go through the code quickly And I will specify, because there are only 3 smart contracts here. The first one is a very, very simple implementation of the NFT. It uses the OpenZeppelin smart contracts, which are a great source of reliable and tested smart contracts. So definitely recommend to use OpenZeppelin in your solutions. If for popular use cases, definitely. So here, the only custom thing is the sequential assignment of token IDs, and that's it. Another contract is the marketplace contract, which basically has 2 most important functions. The first one is the post-sell order, which can be used to post-sell orders. And the second one is the buy function. So once someone posted sell order, you can specify the order ID that you want to execute. And then the smart contract will actually check the expected price, expected amount of native tokens, here the Celo tokens. And if this amount was passed by the transaction sender, then it will transfer the NFT to the transaction sender and will mark the order as executed. And that's basically how it works. And as you can see here, this function uses some internal function called get price from order. And in this standard implementation of NFT marketplace, in the marketplace.sol file, it simply returns the price of the order received from the storage. But in the updated version, which actually uses Oracle data, it also has some logic, which is described here, and which is based on the calculation, the value of the amount of Celo tokens, which is equivalent to the given amount of dollars. Yeah, so these are basically the smart contracts. Let me check the... Okay, so this is basically it. I would also like to show you another interesting resource on our GitHub, which can be useful for you to integrate Redstone Oracles. If you go to github.com/redstone finance, you can find so-called EVM, or you can just type examples, and you will see Redstone EVM connector examples repository, which has a lot of different examples with the smart contracts and with the tests. It will show you how to integrate the custom URLs data. It will show how to integrate some kind of pseudo randomness to your smart contracts. I would not recommend to use it on production, but for hackathon, it's definitely worth integration if you realize some kind of randomness in your smart contract. Yeah, so the basic data, you will see how to integrate them here, how to integrate data, how to create contracts that should rely on other contracts with the Oracle data. Everything will be here. And so yeah, check the contracts folder and the test folder. And I hope it will help you to integrate Redstone Oracles. Yeah, so this is it. If you have any questions, I'll be happy to answer them on chat.
Awesome. Thank you, Alex. So one thing is that we will post all these links in the description of the live stream, the EVM connector examples, and all the documentation links.
Sure.
And yeah, if anybody has any questions, this would be the right time to ask. While we wait for Q&A, I have questions like, let's say I register a custom data URL. Do all the node providers provide the data for that, or there's a node operator side where they get to select, I'm going to provide the data for this and not for this?
Yeah, so all nodes which are in this data service for custom URLs, currently there are 2 nodes there. they will provide the data. They do not select like that some URLs are provided, some not. So yeah, all the nodes from this data service, from this set of nodes for custom data feeds, will provide the values. But we have different data services. So for example, we have a data service that just that is focusing on the main, like for example, 10 most popular tokens. And it just like provides 10 most popular tokens. It will not provide custom data. So custom data will be provided only by this special set of nodes that were launched to provide custom data.
Great. The question would be like, what if some Oracle provides incorrect data? And is there like a slashing mechanism?
Oh yeah, this is a great question, because we did extensive research on this topic, on the kind of staking or slashing mechanism for data providers. And yeah, thank you for the question, because I forgot to mention. Yeah, the idea is that each data provider, before joining the Redstone network, should stake Redstone tokens. And these Redstone tokens are like guarantee that their services will be provided correctly, so that they will provide data consistently, and will provide correct data, which is the most important thing. And if any of these conditions are broken, then this stake will be slashed. But also, depending on different level of problems, the different part of stakes will be slashed. For example, there will be a set of and also worth mentioning, this staking part is not implemented yet. We have smart contracts for it, but it's still just like in the development phase. So as I've said, it really depends on the level of problem with the data. If there are 10 nodes and only one of them provided incorrect data, we would not take the whole stake from this node. We would take maybe 1 or 2% of this stake, because the actual data have not been corrupted because of one node. If you rely on 10 nodes and you aggregate data from different 10 nodes on chain, then the median value will not be manipulated even. But if 5 or even 6 of 10 nodes will provide incorrect values, then there is a big problem, because consumer protocols will be crashed because of this. They can be killed by this. And in this case, all the stake from each incorrect data provider will be used to reimburse, to refund the clients. And another interesting moment is that the funds for the refund will be distributed proportionally to the amount of fees that clients were paying. So for example, if you have 2 clients, the first one pays $1 per month and another one $10 per month, then the second one will receive 10 times more from the refund fund. Yeah, because this is the fair way to do this, the honest way. Yeah, so, and we don't really force some special fees for clients, but if you are a client and you want to have higher level of security, higher level of insurance, you will just decide to pay more fees.
Got it. Makes sense. So I don't think we have any questions. So we can wrap it up. Thank you, Alex, for taking your time. And yes, Alex did mention that we have a bounty for best use case of Redstone, which is top 5 projects building on the Redstone using Redstone Oracles and not API would be rewarded $100 each, right?
Yeah, so each project which successfully integrates Redstone Oracles, not API, to their dApps, will just integrate, will receive $100 each. If there will be more than 5 projects, we'll probably select just the best ideas.
Great. Thank you, Alex, for taking your time and educating the audience about Redstone Oracles.
Thank you very much for having me, and have a nice day. Bye-bye.
Bye, everyone.
Bye, everyone.